Hey everyone, Miss Kennedy here. I'm going to walk you through this reactivity foldable. So by this time, we've learned a little bit about our periodic table and what we can see on there. We're going to specifically get into reactivity. So the periodic table can tell us a lot about the reactivity of our elements. So if you flip this over, we have three separate boxes here. So it says reactivity of metals, reactivity of nonmetals, and reactivity of noble gases. So we need to first color the elements that are metal blue. Hopefully we remember from 6th grade science that anything, and I'm going to darken this because I like this to be dark, anything along this staircase or zigzag line, anything along this except for aluminum, these are all metalloids. Everything to the left is a metal. Everything to the right is a non-metal. So it said to color the elements that are metal blue. I'm gonna find a blue colored pencil. So we're gonna color everything on the left blue. So all of this, color aluminum, leave germanium and antimony, polonium, leave those not colored right now. Everything else is going to be blue. You do not know by now, Miss Kennedy is not a perfectionist. So I'm going to just say color. We're going to leave hydrogen alone. Do not color hydrogen because hydrogen is a non-metal, but it is grouped over here based upon its atomic number, aka the number of protons it has in its nucleus. But we're not coloring hydrogen because it is not a metal. All right, and then it says label them. I'm gonna grab, I'll go purple. It's the closest pen I have to blue. Oh no, I found a blue pen. Okay, so I'm gonna label, it says and label these. So I'm gonna label these metals. Metals, okay. And you know what? I'll add a little thing like this so we know that's like my key. All right, label them and draw arrows to show how the reactivity increases in metals as you move across the periodic table. These are also metals, so I guess we could technically color those as well. When you get into high school chemistry, you'll learn more about these guys and why they're separated and called something different down here. All right, again, Miss Kennedy's not a perfectionist. All right, so we've colored those blue. These are metals. How does the reactivity increase in metals as we move across the periodic table? So across would mean horizontally. So my reactivity increases as I go this way. So I'm going to put increasing reactivity. All right, so I wrote on there how reactivity increases. And then it says on your paper, describe how reactivity changes in metals. So in words, you're going to describe what this arrow is showing. So you can say from right to left, the reactivity increases in metals. You can say something about how this left-hand side, groups 1 and group 2 are my most reactive metals. Then it says the most reactive metal is. So think back to that video where we had those alkali metals in water, and we didn't actually get to see this in real life because, for one, francium is pretty unstable and pretty hard to get a hold of. But I'm going to just circle this. Francium is the most reactive metal. All right, and then it says reactivity of nonmetals. I'm going to put this back up here. On the opposite side, color the elements that are nonmetals red. I'm going to grab my red. So remember, hydrogen is a nonmetal. So let's color hydrogen. This is a nonmetal. And then everything over here. You know what? So technically, we're going to leave our metalloids alone. So we're going to color everything to the right, except for these that are touching my staircase or zigzag. So I'm just going to kind of, and again, Kennedy's not a perfectionist. I admire those of you guys who like to keep stuff nice and neat, but Miss Kennedy doesn't roll like that. Okay. So I'm coloring all of my non-metals red. Oh, sorry. Okay. Red, 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 red. I know I probably have some people cringing because I'm coloring in multiple directions. All right. If I really wanted to, I could always go back and make those prettier. All right, so I colored those red, and then it says draw an X through the group A noble gases. I'm going to use my black for this. I'm drawing an X. Any ideas why I'm drawing an X through my group 8A elements? These are called the noble gases, and I'm going to go ahead. I'm going to just label these. I'm going to write, since I have plenty of room here, I'm going to write noble gases. And we put a big X. So why would we put a big X through my group 8A? We're talking about reactivity, or that's what the purpose of this foldable is. It's reactivity. If I put a big X through these, X usually means like no or don't or stop. I'm also, let's see. Yeah, I'm going to be good there. Okay, so I put a big X. So basically, these don't react. I explained to one class that these are my independent women over here. They don't need anybody. They're good all by themselves. They have a full set of valence electrons. They have 8 valence electrons, meaning they have 8 electrons on that outer energy level. So they are good. They don't need to bond or react with other elements. Let's see, our instructions also say to draw an X through hydrogen. And then it says draw arrows to show how reactivity increases in nonmetals as you move across the periodic table. So my nonmetals, let me see if I have some kind of red writing utensil. I'll just use, all right, I'll use purple for this one. So my group 17, these are the most reactive. These are the most reactive because they have 7 valence electrons. They only need 1. So I'm gonna put, this is kind of funky, actually, draw arrows to show. Okay, we're gonna draw. So my reactivity will increase, but then it's also decreasing. So I'm just gonna draw like this. I'm gonna put draw arrows. I'm just gonna put most reactive. And again, sorry, Miss Kennedy is not a perfectionist. So my group 16 and 17, those are the most reactive nonmetals. Group 16 needs 2 valence electrons to be stable. So they're likely to pair up. If we're gonna just pair up 2 elements, they could easily pair up with my group 2 because they have 2 valence electrons. Group 17 would easily pair up with my group 1 because group 1 has 1 they want to give away. Group 17 has 1 they want to take. What else do I want to put on here? Describe. Okay, so now you're going to put that into words. Describe how that reactivity changes. So again, this one's kind of funky. So it's increasing, going to the right, but that stops at group 18. Group 18 is not reactive at all. And then the most reactive nonmetal, I'll let you guys come up with your thoughts on that one, or refer to the webpage for our atoms or for our periodic table notes. All right, and then it says on the opposite side, label group 8A elements noble gases. Oh, look, I already did that. And then describe the reactivity. So again, these are those independent women. They don't need anybody. They have everything they need. They have a full set of valence electrons. They're good. They don't need to bond. They don't need any more valence electrons. They've got enough going on. They're good all by themselves. So describe that on the other side of this paper. And thanks for watching.